next thing that we have to look at. And there are some hints up here. It says graph the polynomial using zeros and n behavior.
How many x's they have?
Yeah, how many x's do we have?
2.
2, right? So we have a degree of 2. So what does that tell us about what the shape of our graph is going to look like?
It's going to be going down.
Okay, 1, it's going to be going down. That's the negative. What's the 2 tell us? It's an even degree.
It's going to land on a 2.
Okay. Gonna bounce. Good, it's gonna bounce. So we've got these shapes. So let's go back in our head. When we graph stuff, we've got these shapes. Evens, right? Smiley or frowny face, bouncing.
Oh.
Right?
So we have to be careful, I think, with bounce. When have we said bounce? Like it will like turn, it will have a turn, but I don't see this one like bouncing on the x-axis. When would it bounce on the x-axis?
Oh, okay. I got you.
If it had multiplicity, right?
Yeah.
So I think what you meant, Giovanni, is the same thing. I want to make sure we don't
so
use that word.
let's be clear. If this had a 2, right, this would be what we're saying. is a
Multiplicity
bounce.
2 or a bounce.
Yeah. But what we have is a degree of 2.
Mm-hmm.
Okay.
I know.
So what we're talking about is we either have this shape, a smiley face, or a frowny face, or we have a disco.
Mm-hmm.
Well, actually, Ritter used to call it disco.
Yeah, but
sorry.
that makes sense.
But
yeah.
it's this thing.
Opposite.
Okay, we're either going one direction or another. Like Ritter, I work with her, just like disco.
Good.
Okay. So this is going to be a smiley face or a frowny. It's the negatives outside. What does it tell us then? Is it going to be a smiley or frowny? A frowny. It's down. It's sad. It's a frowny face.
It's having a moment.
Right?
It's having a moment.
Yeah, it's having a 2020.
Yeah.
2020 kind of year. All right, so now we have a general idea. What do we know about our zeros? Right there. Like it says use zeros and n behavior. Now we know our n behavior, kind of what our arrows are going to be pointing down. Good, yeah. These up here are our zeros, right? And we're going to pull those out and change their signs. Or we can put them equal to 0 and solve. So we have x equals -2, x equals +4, right? So we're going to pull those out and change their signs. So I can go on my graph.
Mm-hmm.
I'm going to plot on my x-axis -2-ish, right? And 4. Do you want me to take marks or do you care?
Either way, nope, that's fine. And it'll be matching. So you'll just have to match. You won't have to actually sketch it yourself on your test.
Okay. And then it's a frowny face. So I'm going to go through those points, right? Because those are my intercepts. Zeros are x-intercepts. So I'm going to show my n behavior. My arrows are pointing down.
Every time we got to draw the arrows on them, right?
It doesn't really matter. And like I said, it's
The
multiple
shape
choice.
is gonna
Yeah.
tell us. Yeah.
Now, I want 100% on these questions. Why should nobody miss this? You can do it on your calculator. I want to just remind you, type this in on your calculator right now.
Okay.
Okay, so you're going to go into your y equals.
Right. Our y equals is up here.
And then just do the parentheses.
Yep. So right now, make sure your calculator's set so that if you have issues, you kind of clear them out. So mine had a bunch of stuff in, so I'm clearing everything out. I'm going to go to y1, and I'm entering in the equation. Now, on your calculator, there's a negative, the little negative, and then there's this minus. Which one do we put on this equation?
The little negative.
Yeah, so when it has the negative in front, that's just the little negative. So you do negative, and then you type it in exactly the same. I already forgot. X plus 2, x minus 4. So x plus 2, and then parenthesis x minus 4. And then what I would recommend right now, in case somebody else has been using your calculator, let's put it at a standard window. Do you guys remember how to get to a standard window? Yep, so you're going to go zoom 6. Very good. So even if you think you're there, just hit zoom 6. That way your calculator will graph a 10 by 10. For most of our questions, a 10 by 10 is good. You could adjust if you need to. And then you can confirm what it is that we thought. We said it would cross at a -2, +4, and be concave down. Okay, so let's take a look. So this is why I wanted to practice one, so that if there is something wrong, you can put your right equals. You just did that. Oh, I think
The other degrees, they have the
This
shape.
is so much
They have
easier.
squiggles. Now because we do have crossing.
Yes, very good.
This one's-
Try 27 on your calculator.
It goes
It's
like
the
And then I just
general
want to
shape.
talk about it. So sketch 27, type it in on your calculator. I only want to do 2 more problems together so that you have time for your test.
Right, it's weird.
No, you could change your window. You could go to zoom out or go to your graph just really quick. If I wanted to see more, I would have just wanted to see lower. Like I can
No,
tell that's
it's
not there.
the.
So you could go into your window
So.
and I want to see lower, so I change my white and instead of going to -10, maybe go -12.
I gotta
So I usually would just adjust it individually.
Gotta put two times GK.
Okay, so you guys have sketched 27 on your calculator? Oh,
Yeah.
that's right.
Look at
Where is it?
Okay.
It's not about positive-
So
positive or negative.
27, let me catch up to you guys.
So this is a multiplicity.
Okay, so I'm hitting graph. Now, for me, I'm not too concerned that I can't see the bottom of this. Would you guys agree this is just, those two are just gonna kind of turn? Even though I don't see it, I feel pretty good that I know what it looks like without seeing it. This graph is crossing at -4. Does that make sense based on the equation? Look at the equation on 27. Did we expect a -4? Yeah. What about this one here at 1?
But don't look at that.
Yeah. Why is the graph bouncing there at 0? Good. The x was squared. So let me show you again. We had the is it still here? Oh shoot, I lost it. Let's see if mine will reconnect. But you guys have the equation in front of you. It had an x squared and oh good, mine's there. So that's why it was bouncing. Mine should be coming up. It says it's going to connect. Okay, I want to just show one more. But just remember how much your calculator is going to help you. Okay, so we expected it to bounce at 0 because of this multiplicity. That's why it's bouncing here. We saw the +4, we knew -4, but again, we're confirming on our calculator. The -1 was here. There is one that's a little bit unique that I want to talk about. I want to talk about 31. I'm going to clear mine out really quick. Graph 31 on your calculator really quick. Go into your y equals, and we're going to graph. Okay, so we're going to clear this out. I'm typing in this. Okay, anybody want to make a prediction? What is the degree of this polynomial? 3. Everybody okay? The degree is 3?
Yep.
So I expect it to start high and go like it's going to end different. Okay, when I hit graph, also how many zeros will this one have if it's degree 3? 3. You have the same number of zeros as the degree. When I see this graph, I see only one x-intercept. What do you guys know if it has one x-intercept? What are the other 2 zeros? Imaginary. You guys kind of remember this, that if it doesn't cross, it's imaginary. Well, that 2 makes sense because in the parentheses, it was an x minus 2. How do you think you're going to find the other 2 zeros? Because you have a question on your test where I say find the zeros. It's in factor form. I'm going to go back to my iPad now. So let's say I give you this and I say find the zeros. 1 0 is super easy. That's this one. X equals 2. There's 1 0. How do you think we find the 2 imaginary zeros? Your calculator cannot help you find imaginary zeros.
Oh, we have to find zeros?
On one of them, and on a question on your test, it will be similar to this. I'm going to ask you to find zeros.
Will it say that though?
Mhm.
Okay, sweet.
How do you find the other 2 zeros? Yeah.
We just do the box method and then just after distribute a -1.
That would get you to standard form. So I would take your other quadratic, to take our shortcut. This is why I always I don't do the shortcut very often. You take the factor and you set it equal to 0, right? That's why this one is 2. Even if you did the shortcut, that's why it works. The other one will come from here. So I'm going to do the same thing. I would take the x squared plus 1 and set it equal to 0. So
now
what would you do first, Keaton?
Would it the negative player? Oh, you just flip the sign, so -1 over.
Yeah. Yep. So when we cross the equal sign, we change it. So now I have x squared equals -1.
But I have an x squared.
Now you have to divide the x squared.
How do I undo a squared? Square root.
So you have to do it. So it's by square root.
What do you guys notice? What's the problem? It's an I. Do you guys see how we get an I? Imaginary. That's why I'm not surprised. So the other 2 zeros are plus or minus I. Do I have all 3 zeros?
Yes.
Yes. That's why this graph on our calculator only crossed at 2. It looked like this. There was 1 real 0. The other 2 were imaginary. Oh, it's because I slid
Are we gonna have to show work on these?
Nope. So you can use your calculator, but I am just pointing out that your calculator does have limits, and that your calculator can help you find a real one, right? But the imaginary zeros, you just take the other factor and set equal to 0. Yes.
Number
I'm still
30.
confused on question 30.
Okay, type it in on your calculator.
And he did that.
Uh-huh.
But our question is,
Why is it upside down?
yeah.
The reason why this one's upside down, I kind of highlighted it.
Yeah.
It's this negative. If the x has a negative in front, that's why it's going to be upside down.
It's just the same thing.
Yeah, it's just in a different spot. Normally, they put the negative out in front, but if it's mixed in, but again, I'm going to just tell you at this point, because we need to start our test. At this point, if you aren't sure, use your calculator. Yes.
What if like the number in front of the parentheses was like 2x?
Good question. If there was a 2, it's not going to change any of your x-intercepts or zeros. It's called a vertical stretch. We covered this last unit where it would like make it skinnier, but it won't change your
Doing like the x, like finding all of the zeros, you still say x equals 0.
Yep. I don't think I'd give you one like that, but if it did happen, you are correct. Yes, Rich.
Do you just find degree by picking up the smallest x?
So you add all of them up if it's in factored form. I'll pull up one quick review of degree and then we'll start. So I could give you a polynomial in standard form. If I gave you a polynomial in standard form and asked for the degree, what is the degree?
5.
5. So when it's in standard form, you do not add the powers, right? It's separated by plus or minus, your degree is just 5.
You're looking for the highest degree because it's not always in order.
Correct.
That's a test.
Correct, yeah, so they may have it out of order. If I give it to you in factored form, like x squared plus 1 times x minus 7, then if it's a product, then you'd have to multiply them together. Then I would say, oh, well, if I did multiply all together, I would get an x cubed, so the degree would be 3. So you would add them if it's in factored form. Make sense? That's a good question because that comes up. Yeah.
Can you do number 9?
Really quick. I don't want you guys to run out of time. If you run out of time, it's bad. Okay, very last question. 19. I'm just going to show you really quick because I think we did it yesterday. So if you're doing synthetic division, you take the 0 from the bottom. So 2 makes this be 0. So that's why we put a 2 in the box. We listed the coefficients. It went 3, 2, 1. So we listed them in order. We didn't need a 0. We dropped the 4. Our rule is we multiply 2 times 4, we got 8, and we add. Your remainder, you just read over that 36. If you are set, you can go ahead and take out your Chromebook. You have your Chromebook, you have that. I did make copies, only I want you to still submit your answers on Canvas. But if you're like me, I like to be able to write on the questions. So you do have a hard copy of the test as well.
Are we going to collect this out?
Yes, and we will collect this. So that's why there is a spot for your name. You can, but if you want, so you don't have to like copy the equation from the there. So I'll give it to you, but you choose not to.
Yeah. Okay, so Ms. Brown and I talked about it, and a couple of you want to come over and rotate into my class to have a smaller classroom, or maybe you think you'll have more questions and you want to